All right, ladies and gentlemen, we are getting started. But before we can start today's lesson, we need to go back in time like 2 weeks. We graphed exponential functions. For example, y equals 2 raised to the x. We learned how to graph that. We made a little function table.
You want us to write this?
Yes, please. All right, and we chose like -1, 0, and 1 are great points to choose. So what this was 2 to the -1. So what that means, in order to get rid of the negative exponent, we send it to the bottom of our fraction, so it becomes 1/2. So my first point is back 1, up a half. That was my first point. My second point, 2 to the 0. Anything raised to the 0 is, so what that means is unless this graph is being translated, every single exponential graph will have a point at 0, 1, unless it's being translated. That would be good to know. And now we go 2 to the first power, which is 2. So over 1, up 2. Where was our asymptote on an exponential graph?
0.
Y equals 0, correct? It's your x-axis. So it gets really close, but it doesn't actually touch. And then it curves up and looks something like that. Well, I think I told you on Monday that a logarithm is the inverse operation of a exponential. So if you remember back, when we did inverses, we said inverses is a reflection over y equals x. So that is y equals x, and this graph should just fold over that, reflect over that line. And with inverses, we said you can just switch your points, correct? So instead of going -1 up a half, I'm going to go over a half and down 1. So over a half and down 1. Over 1, up 0, and over 1, up 2. Yes, all I did is my points were -1 half, 0, 1, and 1, 2. So the inverse for that, I would just switch the points. So it would be over half, down 1, over 1. Oh, I put that point at the wrong spot. Over 1, up 0, and then over 2, up 1. Thank you, Kyla, actually, for saying that, because I messed up. All right, so over 2, up 1. There we go. That looks much better. So before, on the exponential graph, I had a horizontal asymptote. Now that this is a logarithmic, what happens to my asymptote? It now becomes...
Oh, I'm stupid.
No, you're not.
You can just read it like that. The wrong spot.
And now my asymptote becomes vertical. So I'm going to write that down here. Log graphs have vertical asymptote. Yes.
How do you spell
asymptote. Asymptote. Sometimes it sounds like I say tote, but I'm really saying tote. Some other things we need to know about exponential graphs. Since our asymptote is now vertical, that's our asymptote, our domain is x is greater than 0.
Does that mean the range will be all real numbers?
Our range will be all real numbers. Good job. Our asymptote is at x equals 0. What does what say?
So it's like, normally the domain is all real numbers, not the range.
Yep, because our graph reflected over this. So our horizontal went vertical. Because it's the inverse, it's the opposite pretty much. All right, something we need to know. If we have f of x equals log base x minus h. I'm choking, but thank you. I appreciate the effort. Plus k. Have we seen anything like this before? Yes. So this is in parentheses. What do we know about it? It's a liar. So it's going to control left to right. But if it's positive, it goes left. If it's negative, it goes right. K controls up and down. It's not a liar. If it's positive, it goes up. If it's negative, it goes down. All right, we have 2 graphs and 2 triads, and then we're done for today. All right, example 1. Graph f of x equals log base 4 x. Alright, draw a graph. It doesn't have to be as big a graph as the one I did on the example because we're not drawing the...
Is this the one where we have to do
Wait, what is the 4 do?
I'm going to explain in a second. I don't know, Kyla, hold on. Yep, give me just a second. Let me draw this. Man, we're awful needy today. It's not just you. Yeah, I have no idea where that came from. All right, Liam, you asked what does the 4 do, correct?
Yeah.
I'm going to explain right now. All right, we're going to make a function table. And I'm about to go yell at some kids in the closet. All right, if you look at this right here, this is the most important thing you can write down from today's lesson. I could. All right, so xy. I know that, remember I said that this is a inverse of a exponential graph? Every single exponential graph that's not being translated has a point at 0, 1. So therefore, every single logarithmic graph that's not being translated has a point at 1, 0. So I know that. That's given. 1, 0. I know that's the case. You don't understand that? All right, Jonna. All right, on an exponential graph, when you have any number raised to 0, your answer is 1. So that means I'm going to have a point at 0, 1 on any exponential graph that's not being translated. Well, this is the inverse of a exponential graph, which means we just simply swap the x and the y. So instead of 0, 1, we're going to have a point at 1, 0. So I know for every single graph that's not transformed or translated, it's going to be at 1, 0. The next thing I know is my base, and on this case, my base is 4, so I'm going to use 4 here, is going to have a point at 1. we're only using 2 points to graph a logarithmic graph. Because if you remember back 2 days, I said calculator only works in base 10. And what base is this? So it's useless to you. So I'm going to go over 1, up 0. Put a point there. I'm going to go over 4. 1, 2, 3, 4, up 1. Put a point there. Where is my asymptote? X equals 0. So I know I'm not allowed to touch that line or cross that line. So we're going to go up, curve around, go through this point, and congratulations, you just graphed a logarithmic graph. Unless it's being translated, which guess what we're doing next? Well, we're going to do a try it like this, and then we're going to. Yes.
For log graphs, will the asymptote increase like that?
Yes. We're not that far along yet. But yes, it will. All right, this is a try it. So now, Jonna, if you have a question, I will gladly help you. You're so lost, Jackson, did I hear?
Yeah.
On this? Okay. All right, this is given. This right here is given to us right here. This graph, that is facts. If it's not being translated, that is stone cold truth. So, what? Is it what?
Translated?
Moved. Right, it's not being moved. Because if you look up here, we said x minus h plus k. There's nothing, it's just log base. There's no numbers after it. We'll get to that in like 5 minutes. It's just the number that's subscript. Where the graph crosses the x-axis. Well, it's over 4. It's over base up 1. So it's not the exact x-axis because every graph crosses at 1, 0 unless it's being translated. Because if we were to make a function table, that's the way it would always come out. You always have 1, 0 on a logarithmic graph. Let me put it on the board and then I'll help you. All right, ladies and gentlemen, this is a try it. Y equals log, and my base is 1/4. It's really not that hard. It's not. You're a little mean. You is. Is too. My mom is dead. Be nice. All right. So, Jackson, is this graph going left or right or up and down? Is there anything after the x? No. So it's not. So I know automatically I need to have a point at 1, 0. Annalise, Jonna, we have to have a point at 1, 0 because our graph is not going left to right or up and down. Why is it not going up or down? Because there's nothing after the x telling it to go left or right or up and down. Our next point is our base. What's our base? So 1/4. And what is the accompanying point with your base? 1. Now you can graph that. That's all you need to graph this. Yes, because if we were to make a function table, which I can show you later, it would always come out to be like that.
Oh yeah, so I don't go eyes on 1 every time.
What's that?
I go eyes on 1 every time.
I'll show you later. It's just when we make a function table, that's the way it comes out. I can show you later, but I want to get through the lesson and then I'll show you. All right, so let's draw a graph. It doesn't have to be a big fancy graph. We're only graphing 2 points. It could, but it doesn't have to be. All right, so I'm going to go over 1, up 0, put a point there. I'm going to go over a fourth and up 1. Over a fourth. So cut it in half and cut it in half again and then go up 1. Where is my asymptote? Has the asymptote moved at all? No, so it's still at x equals 1. But if you notice, 1/4 is less than 1, right? So it's going to be getting smaller. So it's going to look something like that. As long as you have anything that looks like that, you are good. It's 0. All right, my domain is x is greater than 0. My range is all real numbers. And my asymptote is not at all, it's x equals 0. On your homework, it asks what is the domain, the range, and the asymptote, and how it's moving. That one didn't move, so I didn't put anything.
Domain is 70.
Domain is x is greater than 0. All right, example 2. Graph log base 2 parentheses x plus 3 minus 1. All right, let's draw a graph. Once again, this one doesn't have to be a massive graph either. It just needs to have at least 4 points. Go forward, left, and right. Up and down will be good. I will in a second after I finish drawing my graph. Welcome. All right, so on this one, our asymptote is normally at x equals 0, correct? But what is the parenthesis telling us to do? Move our asymptote which way? To the left, 3. So I'm going to go 1, 2, 3, and that's my new asymptote right there. So now, I think as it says on the board here, normally, if this wasn't being translated, we would have a point at 1, 0 and 2, 1. If it wasn't being translated. But what's happening to our graph? It's moving, correct? So what I need to do is, it's moving to the left 3, correct? So I need to take my x value and subtract 3. So this is really x minus 3. And what's happening to my y value? That's going down 1, correct? So I take my original y value and I subtract 1. So what's 1 minus 3? Negative 2. What is 0 minus 1? Negative 1. Okay. So now the same thing. We start at 2, but I subtract 3. What's 2 minus 3? Negative 1. And now I take my y value, which is 1, and subtract 1. 1 minus 1 is 0. Let's graph these points here. So I go back 2, down 1, and put a point there. I go back 1, up 0, and put a point there. Now, I know I'm not going to cross my asymptote, so it comes up, it curves through, and it just goes to the right. And this is a sketch. This is not an exact graph, so as long as you get it close, I am happy. Now, on your homework, it wants to know what is your domain. Our domain is normally x is greater than 0, but what happened to our asymptote? It moved to the left, so it's going to be x is greater than negative 3. Our range is all real numbers. Our asymptote is x equals negative 3 because it moved 3 places to the left. And how did our graph move? It went left 3 and down 1. That's exactly like your homework right there.
How do you know it went down one?
All right, let's try it. I'll give me just a minute and we'll do a try it. All right, can I turn the page? Anyone need more time? Jolie, Jojo, pick a number from 1 to 12, please. I would go higher than 6, personally. 7, okay. This is homework number 7. Also known as a try it. This one is. Normally they're not. No, because Jolie let me go home early, so I didn't have to do the scoreboard for lacrosse. So that's why I chose her. Right, Jolie? Jojo? All right, please try this one, and I'll pass out the homework while you are trying this one. You will have the rest of today and all day tomorrow to do this assignment. And the good news is you don't need to draw your own graphs. No, what are you doing? My computer shut off. I did. I asked it what it was doing. I didn't listen. We're good. Yes. Okay. Let me draw my graph and then we'll take a look.
Because I have like the domain and like that's the
Oh, hold on. I would love a banana.
Where's the middle one? There's the middle one.
Do you need a pencil? You can do what we've been doing.
So we always do 2-1?
Yep. Well, it's your base. If you look up here, Kyla, see it's your base. And on this one, our base is 2. So that's where it would be if it wasn't translating anywhere, correct?
Yeah.
But what is happening to this graph? It is going to the left, correct? So really I need x minus 2, comma, y. My y's are not going to change because it's not going up or down, so I can just write 0, 1 right there. We started off at 1, and I need to subtract 2. What's 1 minus 2? Okay. What is 2 minus 2? All right, let's graph. Back 1, up 0. Over 0, up 1. Where did my asymptote go?
Oh wait.
Over how many?
2, but
To the left.
yeah.
So that's my asymptote.
0, 1.
So now this is just going to look like this. It's going to ride up your asymptote. I'm not sure that sounds appropriate.
Nope, it doesn't.
I'm sorry.
Yes, take the pass. All right, so now what it wants to know, according to your homework, is it wants to know what is your domain. Our domain is x is greater than negative 2. Our range is all real numbers. Our asymptote is x equals negative 2. And how did our graph move? It went left 2.